In this problem, we are given two trigonometric equations. So using these two equations, we need to prove the following. So let's begin. So first, we will note down whatever we have been provided with. So here we are given ax over cosine theta plus by over sine theta. So it's given here that this is equals to a squared minus b squared. We're going to label this as equation number 1. And we're given the other equation ax divided by cosine squared theta times sine theta. So this is equals to by over sine squared theta all multiplied to cosine theta. So this is equation number 2. We will start with equation number 2. So using equation number 2, we can obtain the value of sine theta and cosine theta, and once we have those values, we can use the first equation and replace the cosine theta and sine theta with the value that we'll obtain in a moment, and using that we'll be able to prove the given equation. So let's begin. Now what we'll do, once starting with equation number 2, we'll cross multiply it. So we're going to get ax times sine cubed theta, which will be equals to by times cosine cubed theta. So what we'll do, we will rewrite this equation as sine cubed theta divided by by. That will be equals to cosine cubed theta divided by ax. Now let's raise each side to the power. So we have sine cubed theta over by equals to cosine cubed theta over ax. So we're going each side to the power of, we're raising each side to the power of 2/3. So we have cosine cubed theta over ax will raise to the power of 2/3. This is now going to give us sine squared theta divided by by whole raised to the power of 2/3, which will be equals to cosine cubed theta whole raised to the power of 2/3 will give us cosine squared theta divided by ax raised to the power of 2/3. Now there is a property of ratio and proportions that says that if we have a ratio A is to B equals to another ratio C is to D, then this will be equivalent to A plus C divided by B plus D. So we can use this particular property to obtain sine squared theta over by raised to the power of 2/3. That will be equals to cosine squared theta divided by AX raised to the power of 2/3. That will be now equals to sine squared theta plus cosine squared theta whole divided by by raised to the power of 2/3 plus ax raised to the power of 2/3. Now sine squared theta plus cosine squared theta, that is a standard trig identity whose value is always equals to 1. So that means our numerator is simply equals to 1, which gives us, let this be equation number 3. Now we will be using equation number 3. So from equation 3, what we're going to do, we're going to pick up sine squared, the ratio sine squared theta divided by by raised to the power of 2/3, and this is equals to 1 divided by ax raised to the power of 2/3 plus by raised to the power of 2/3, which can be also expressed as sine squared theta equals to by raised to the power of 2/3 whole divided by ax raised to the power of 2/3 plus by raised to the power of 2/3. So if we take the square root on both sides, we'll get the value of sine theta. We're going to consider only the positive square root. So sine theta then will be equals to by. So square root of by raised to the power of 2/3 will be 1/3, b raised to the power of 1/3, which will be divided by square root of ax raised to the power of 2/3 plus by raised to the power of 2/3. So now we have successfully obtained the value of sine theta. We're going to refer to this as equation number 4. So if you use the second ratio from equation number 3 and the third ratio and equate them, this is also going to give us, so using 3, we also get the value of cosine theta. So I'm leaving this as an exercise for you to try it on your own. So we have cosine of theta, this will be then given by ax raised to the power of 1/3 whole divided by square root of ax raised to the power of 2/3 plus by raised to the power of 2/3. So let this be equation number 5. So we've successfully obtained a value of sine theta and cosine theta. Now we will go back to equation number 1. So we'll start with equation number 1, which is ax over cosine theta plus by over sine theta equals a squared minus b squared. Now we have ax divided by cosine theta, which can be replaced with this following equation. So we have ax raised to the power of 1/3. Now since it is divided by the denominator, so that gets multiplied to give us ax raised to the power of 2/3 plus by raised to the power of 2/3. This will be now added to by divided by sine theta. So sine theta is by raised to the power of 1/3, and whole ratio is multiplied to ax raised to the power of 2/3 plus by raised to the power of 2/3. So this will be equals to a squared minus b squared. Now from the two terms on the left hand side, we can take square root of ax raised to the power of 2/3 plus by raised to the power of 2/3 as the common factor. So with this will now get multiplied to, so we have ax raised to the power of 1 divided by x raised to the power of 1/3. That means we have ax raised to the power of 2/3. Similarly, from the second term, we have by raised to the power of 1 divided by by raised to the power of 1/3. So we can combine them to get by raised to the power of 2/3, the whole raised to the power of 1. Now this will be equals to a squared minus b squared. Now ax, this can be also expressed as ax raised to the power of 2/3 plus by raised to the power of 2/3. So since we have a square root, so we can raise entire expression to the power of 1/2. And we also have the same expression multiplied to it with the power of 1. So 1 will get added to the half, which will be equals to a squared minus b squared. So this is going to give us ax raised to the power of 2/3 plus by raised to the power of 2/3. So a whole raised to the power of 1/2 plus 1. So that's 3/2, which will be equals to a squared minus b squared. Now we want to get rid of the power 3/2. So we are going to raise both sides to the power of 2/3. So that's finally going to give us ax raised to the power of 2/3 plus by raised to the power of 2/3 whole raised to the power of 3/2. But what we'll do, we will raise to the power of 2/3. Similarly, on the right hand side, we have a squared minus b squared. So we're going to raise it to the power of 2/3. So 3/2 multiplied to 2/3. So that will get again, that will give us a value 1. So finally, we can say that ax raised to the power of 2/3 plus by raised to the power of 2/3. This will be equals to a squared minus b squared whole raised to the power of 2/3. Hence proved.